So what I'm going to talk about today is optimizing your whole building investment. Notice I didn't say energy, I said your whole building investment. And when you look at the total cost of building ownership, deep retrofits of existing buildings and new high performance net zero buildings will save the equivalent of the capital cost of the building. You build $1 million building, you're going to save $1 million in life cycle cost. Pretty straightforward. And if you've got a portfolio of buildings, there's more opportunity for cost savings. I'm not going to talk about that today. So building owners have four major problems. First one is they never have enough buildings, particularly if they're low-income housing providers. They never have enough space. They have large and growing maintenance backlogs. So the maintenance backlog means the amount of maintenance work that you need to do to maintain that building. So if it's your house at home, it's basically the cost to put in new windows, put on a new roof, new heating system, whatever. That's the maintenance backlog. And the maintenance backlog that we see in many buildings is about $1,000 per square meter or $100 per square foot. So we're spending only, a new building today, you could pay about $300 per square foot. So $100 per square foot on an existing building is about the third of the cost of a new building in maintenance backlog. So it's a huge number, and the problem is nobody is addressing that. Nobody is spending the money to look after that. The other thing is building owners are being asked to reduce their greenhouse gas emissions, which costs money, but on the other hand, they're also having to pay for the carbon tax, which is increasing their cost. And at the end of the day, none of them have any solutions for these problems. They deal with certain pieces of it, but they're not dealing with the whole problem. So what most people are doing is they're focusing on the design and construction cost. And as you can see in the slide, design and construction costs are very, very small. They're only like 10% of the life cycle cost of the building. So 90% of the cost of building ownership occurs after the construction is complete. And if you look at it a different way, if you have $1 million building, your life cycle costs are going to be between $7 and $10 million. So it's big money. And so what we need to do is shift our thinking from low first cost to low life cycle cost. And everybody says, oh, I don't want to spend any extra money on building a high performance building. Well, I'm going to show you that it's worth it. Okay? So what is the total cost of building ownership? Well, just imagine for a minute you have a cookie jar sitting on the counter, and every time you get a bill associated with owning and operating that building, and we're talking about major costs, but I mean, you could get down to kitchen faucets and doorknobs, but we're typically dealing with the major costs. But if you take all those costs, and one of the ones that people are not thinking about today is the transition to renewable energy, but you're going to have to do that before 2050. But if you take all of those costs and add them up, so all these bills go into the cookie jar, and at the end of the year you add them up and you add them to the previous year, what you get is an ever-increasing cumulative total cost of building ownership curve. It's always going up. Now, a more sustainable building will have a flatter curve, and that's what we're after. And that's what these builders here today that are doing passive house buildings, they flattened that curve, and it's a big flattening. It's worth big dollars to you. So I'm just going straight into a couple of case studies. And what you're going to see from these case studies is this applies to any size building. It doesn't really matter. This is a big building, Ontario MERB, almost 21,000 square meters of floor area. It was originally designed as a code-built building. The owner then said, well, what happens if we made this a passive house building? What more would it cost? 1.2% more, okay? On big buildings, the percentage is not huge. Smaller buildings, it's bigger, okay? And then if you add solar panels on, it increased to the 60.7 million or 4.8% premium. So that's within the construction contingency of any of these big projects, which is typically 10%. But the total cost of building ownership savings is $73.5 million. You invested 60, you're going to get $73.5 million back in life cycle cost savings. So where are we getting these numbers from? Well, we're comparing a base case code-built building to a passive house building and then a passive house building with solar. And what we see is, you can see the 60-year total cost of building ownership is on the next line, 177 million, 131, 103 million. But basically what you're seeing is a $45 million saving for the Passive House building and a $73 million saving for the Passive House building with solar. So it's a big deal. But what's more important, if you look at the cumulative total cost of building ownership curve, is you look at the red line as the co-built building, the green line is the Passive House building, and the Passive House building with solar is the purple line. Those savings are exceeding expenses before 3 years, okay? So in other words, the amount of money, extra money that you invested, you've got that money back within 3 years of construction, okay? So new construction is an absolute no-brainer. Why would anybody build anything else? It's huge. This is a single-family home in Nova Scotia. It was a retirement home for someone. And initial design for the co-built building would be $437,000, and then the Passive House building was $516,000. Additional investment, $79,000. Pretty big premium, right? Okay, but we still got $1.5 million in life cycle cost savings. So you invested $500,000, and you're going to get $1.5 million back in life cycle cost savings. So it's a big deal. And so when you're looking at the total cost of building ownership and comparing the code-built building to the high-performance building with solar, what you see is you got a 90% greenhouse gas reduction, a 91% reduction in the energy consumption, and a 50% reduction in the total cost of building ownership. So savings are a big deal. And in this case, if you look at the red line is the co-built building and the green line is the Passive House building, these lines now are crossing before year 3 in this example as well. So I want to now talk about retrofits, because there's a lot more existing buildings than there is new buildings that we're building. This is an Ontario MURB built in 1960, 700 square meters. It had a maintenance backlog of $712,000. That $712,000 was for new windows, new doors, new roof, new heating system, complete heating system, new plumbing system, including all the piping, because it was cast iron and it was now over 60 years old. So it needed everything. And the replacement cost of the building is about $2.1 million. The deep retrofit cost is $1.3 million. So it's still worthwhile doing this. But your life cycle total cost of building ownership savings are $3.5 million. So I mentioned before the $712,000 of backlog, and it's 700 square meters, $1,000 per square meter for that backlog. It's a huge deal. So in this case, we're comparing the code-built building to a Passive House deep retrofit, R40 roof, R25 wall panels, and then all the other things, the new windows, the new doors, new plumbing, heating system, new kitchens, new bathrooms, the whole deal. And then we also had another comparison where we're doing the same renovation with adding solar panels. But you can see there's some trees in the background that would have shaded the solar panels, so that kind of went by the wayside. But the greenhouse gas reductions went from 41,000 down to 1,200. We've reduced the energy use index from 450 down to 53, and we've got a 31% saving in the total cost of building ownership. So pretty big savings. So this is the total cost of building ownership curve again. Code-built building, the red one, and the gold line is the Passive House building. Notice in this case, these lines are not crossing until about year 15. So it's going to take you 15 years before you recover, or their savings exceed expenses, okay? But you still save $3.5 million. So you have to have a much longer view of what's happening. And so people say, well, I'm not going to live in the building for 15 years. Well, is the building going to last more than 15 years? This building would be totally renewed. It'll have another 60-year life easily. So people need to think about the life of the building, not how long they're going to own it. And there are some methods to transfer that value in that high-performance building to other to the new owner. So what we need to do is change how we do things. Not substantially, but we need to make some changes. And I'm going to talk about the current design process, and then I'm going to talk about the changes that we need to make. So anybody that's in the construction business knows that you get a budget, and you always have a budget, and you're supposed to design it not to exceed that budget. And then typically what happens is you design that building to code, okay, or the building enclosure to code, and you try and decrease the energy consumption with a mechanical system, and the fancier, more complicated it is, the better. And we'll talk about that more in a minute. And then when the cost is too high, what do? Well, you apply what I call devalue engineering. And I experienced this just today. There's a nursing home going up in Nova Scotia that I'm involved with, and the general contractor sending back a list of all the things he wants to do for value engineering. And every single one of those things is going to increase the total cost of building ownership. Not decrease, increase, because he's just reducing the capital cost. So the owner will get a building that meets their budget, okay, and it'll meet code, okay, but he has a high operating and maintenance cost forever. And those operating and maintenance costs are going up to 2, 3, 4% per year on average in the long term. Currently, it's going up more than that. So what do we need to do differently? Well, we need to educate the design team, and I should add the owner to this, about the total cost of building ownership, okay? And the second thing we need to do is we need to have an integrated project delivery team. We can't be doing this by one trade or one architect or one engineer. It takes a whole team of people to make this work. And you have to pay attention to the detail. Passive House works because we pay attention to the detail. And so that design team is going to look at all costs, not just the cost for construction, but also the operating and maintenance costs, because those are a big deal at the end of the day. And we need to have a goal. We need to design to a net zero goal. There's a building going up, and I'm not going to say where it is. It might be in Winnipeg. But the owner built this building, and he wasn't happy with the performance of that building. So he hired a new engineer, and he hired a new architect, a new contractor, and he said, reduce the energy consumption. Well, a 1% improvement would satisfy that requirement. If he had given him a net zero goal, the design team would have had to do some work. But they're capable of doing it. This isn't difficult. It's just that we have to set the goal, and then we'll get there. We need to design a high-performance building enclosure, and that's what Passive House does. We need to have a good mechanical system, probably with geothermal, but not using fossil fuels. And we want to keep that system as simple as possible. And then we want to add renewables after we've done this, because the amount of solar panels that we need is less, which means the capital cost is less, and which means the maintenance cost is less, because these things do have maintenance. And we need to optimize the design based on the lowest total cost of building ownership. So if you want to say, should I put in a ground source heat pump or an air source heat pump, you can evaluate that. Should I put on asphalt shingles or metal roofing? You can analyze those kind of things. And if you analyze it based on life cycle cost, you're going to make the right decisions. And at the end of the day, you have the savings. The savings are significant. So let's talk about the savings. So if this is the capital cost of the building, you're going to spend maybe an extra 5 to 10% more if the design team is good for a high-performance building. But your savings are equal to the replacement cost of that building, which is pretty substantial. So build $1 million building, save $1 million in life cycle cost. And this is an existing building. It's almost the same story, but each building has a current replacement cost. If you had to rebuild that building today, what would it cost? But when you have to go and do the deep retrofit, you have to spend a considerable amount of money. It's usually a fair bit of money. It can be $200 to $300 a square foot, maybe as low as $150 if you're good at it, but it's a lot of money. So a portion of that retrofit money is maintenance money that you're going to have to spend whether you want to or not. Okay? And so what do you get out of it? You get the savings equal to the replacement cost of that building. So what is the big deal at the end of the day? High performance buildings and deep retrofits with solar panels going to achieve net zero and reduce the 60-year total cost of building ownership significantly. The order of optimizing is extremely important. You need to reduce the load first. That means building a good building enclosure to passive house level standards. And when you choose building materials, you need to choose building materials that are very durable. And we also need to get a lot better at doing deep retrofits. New construction, I think we're almost there. There's a lot of education required yet for mainstream builders, but they're getting there. But retrofits, we need a lot of work on reducing the cost. We need to electrify, probably using heat pumps to reduce greenhouse gas emissions. And then we add solar at the end because that's which provides the lowest total cost of building ownership. And you need to optimize the building right from day one. You don't start at we're just ready to hammer nails. No, you need to start that right at the very beginning, and that's when you're going to get the best results. And you can't go part way to high performance and then hope to get further later. You got to do it the first time. That's the most economical way. And then these buildings have higher value at the end of the day. And that value is really important because you want to be able to transfer that value, that investment that you put in your building, into a new building. And you need to provide that information to the appraisers because typically they just say, oh, here's this building and here's one that compares, so they're the same. Well, one could be a passive house building and one could be a conventional building, and they have the value of the passive house building is much higher. So that's all I have. Thank you.